Hey everyone, welcome back to my channel. If you are new here, I focus on openSUSE Leap and Tumbleweed Linux. Today we are diving into a super exciting topic, Rust programming on openSUSE Leap. Rust has been getting a lot of attention for its performance and memory safety, and it's perfect for system level programming. We will cover everything from installation, setting up your IDE, and building your first Rust project to useful real-world examples of Rust code. Let's get started. The first thing we need to do is install Rust on openSUSE Leap. It's quite simple using the official Rust installer. So let's fire up our browser and let's go to rust-lang.org. Press get started and let's copy this command. Let's open our terminal and we just paste and press enter. So to explain, this command downloads and installs Rust using curl, which fetches the install script securely over HTTPS using the --proto for protocol and using the TLS version 1.2. Hit enter and the SH at the end tells the terminal to execute the script once downloaded. So choose one, press enter. Follow the prompt to proceed with the installation. Once the installation is complete, we are going to add Rust to our path. So we have to wait for the installation. Now the installation finished. So now it's giving us some good information here to get started. You may need to restart your current shell. And to configure your current shell, you need to source the corresponding env file under home cargo. This is usually done by running one of the following commands here or here. But before to do this, try and open your bash rc and let's check the last line. So the installer already add that line for us. So if you are lazy and you don't want to open a new terminal to activate this, so you can just take this copy and press enter and that's it, it's activated. And to make sure about it, we can run rust c and version. So as you see, this command checks if the Rust compiler rust c was installed correctly by printing the installed version. So now we have Rust installed on our openSUSE system. Now that we have Rust installed, let's set up VSCodium for Rust development. If you haven't installed VSCodium yet, you can refer to my previous video, Master Rust Programming on openSUSE. Install, set up VSCodium and code like a pro. Once VSCodium is installed, let's open it and let's head to the extension tab. Let's maximize this and we go here. The one we need is Rust Analyzer. Let's see to come up. Okay, it seems it's doing some kind of update in the background. Let's give it some time because VSCodium also has its own repository. Yeah, so let's check this one. Yeah, let's install this one and okay, what is the analyzer? We want this one, Rust Analyzer. Yeah, this one. Let's install it. and yes, so that's good to go for now. So just to explain, Rust Analyzer extension helps developers by providing auto-completion, syntax highlighting, and other helpful features like code suggestions and error checking as you type. Now let's create our first Rust program. In your terminal, navigate to the directory where you want to create your project and run the following command with me. So before we create a new project, let's create a working directory for us. Work dir setter, then we go here and then cargo new hello Rust, press enter. So cargo new hello Rust creates a new Rust project. Cargo is Rust's package manager and build tool, and this command sets up a new directory with a default project structure including the source folder and a basic main.rs file. So let's change to our new project folder and Codium. So what I did here is cd hello Rust moves into the new project directory. Codium space dot open the current directory in VSCodium, making it easier to edit the files in your project. So let's write a simple hello world program. Open this file, main, okay, and let's change this to hello openSUSE Rust and save the file. Just a simple explanation about what we are seeing here. The fn main defines the main function, which is the entry point for every Rust program. It tells Rust where to start executing the code. Println is a markup, not a function, that prints text to the console. The exclamation mark indicates it's a markup. The text is the string that gets printed to the console. So if you want to run the program from a terminal while you are opening your VSCodium, you can just press Ctrl Delta tilde and you run the command cargo run. Cargo run compiles and runs the Rust program. Cargo takes care of building and executing your project in a single command. So let's hit enter. And now it compiled the program and printed the message here. Let's now look at a real world Rust example. By building a simple command line tool that counts the number of lines in a file, let's close this and we back one up level in our working directory, and let's run cargo new line counter, hit enter, and we go to that project directory. Cargo new line counter creates a new Rust project named line counter, and the cd line counter moves into the project directory. So let's open it using Codium. And now let's write the code to read a file and count its lines. So let's open the file, src main. Okay, you can leave this main and we go up and we will write the following: use std m use std my system file and use std for standard IO sub and buffer read. Okay, and use std path. Okay, so to explain what's going on here, the use std env allows us to interact with the program's environment, such as reading command line arguments. The use stdfs file enables file handling, letting us open files from the file system. And the use stdio self and buffer read gives us access to input-output functionality, including buffer reading, which we will use to read the file line by line. And here the word used is the same like import in other languages. We are importing a library that contains a predefined functions that bring functionality to my program. And the last one, use std paths, lets us handle file path in a platform independent way. So now let's define the main function and start processing the input file. So let's go here and we delete this and we start writing an actual code. So let args or arguments, it's my variable name, vector, and this vector will be string, okay, equal env args and collect, okay, and if args dot len, the length not equal to, do the following: e print ln and usage p file path, okay, and name the arg, the first one, okay, and return. Also, you don't have to return, but to end it. So to explain what is going on, the first one, let args vec, this one here, captures the command line arguments into a vector string. The first argument, args brackets 0, is the program name, and the second is the file name. Here we are testing or checks if the correct number of arguments is passed, in this case the file path. The ePrintLn prints an error message to standard error output if the user doesn't provide the correct arguments. Okay, so let's continue writing our code. Let file path equal and okay, if let, okay, lines equal read lines. I will explain when I finish writing what is going on here. File path, okay, we do the following: let count equal lines dot count and print and macro number of lines, okay, here count, so else p print then okay, error reading file. Okay. So what's happening here is this one let file path arg1 assigns the provided file path to file path, and the second one read lines file path attempts to read the file lines. If successful, it proceeds, otherwise it prints an error. Lines.count counts the number of lines in the file and prints the results to the console. So let's go here and write a helper function to handle reading lines from file, and here is the main. So we go write another function called read lines. Okay, file name, and again I will explain after I finish writing. IO result. Okay, IO lines, and again IO buff reader near file. Okay, and here to continue where b as ref path and right here let file equal file open file name, and here IO buff reader new file dot lines. Okay, and so what happened here? Here this line, okay, is a function that takes a file path and returns an iterator over the file's line. The p as ref path is a trait bound that allows the function to accept any type that can be converted to a path. Excuse me. And file open file name tries to open the file. The question mark operator propagates the error if the file cannot be opened. And the OK open brackets, close brackets, IO buffer read wraps the file in a buffer reader and returns the line iterator. So let's save this and let's run cargo run and see. Yeah, we have some errors here, so name it a mistype. So yeah, let's figure out what is going on here. Yeah, we forgot the open and closing brackets here because it's a function. So let's save it and let's run again. So our program is compiled now and ready to be used. Let's clean this, and to let you know, the final program for you to use is under this folder here, target. Okay, and inside debug, and you will see it inside the build. Okay, so let's check this. Target, debug. Yeah, so as we can see, this is our program here, line counter. Okay, so let's try to run our program now, and let's use for an example etc pass wd, press enter, and now it's printing the line numbers for that file. For the second example, we will build a basic web server using the Actix Web framework. So let's go to our directory again for Rust, and we do cargo new, and we can call it, yeah, it's Actix Web server for our new program. And let's go, you know the drill, to go inside this folder, and let's open Codium here. Before anything, you go to project dependencies file, which is cargo toml, and let's add this line, Actix web equal, and here you can put asterisk to grab the latest one, and as I said, that Actix Web is a popular web framework in Rust, and this line will add a dependency for the project to make sure that this package will be added to our project. So let's save this file, and now we go ahead and we open our main, and let's use some library here, use Actix _web and web map, app http server and responder. Okay, and semicolon, don't forget, and let's write our main function. Here we need to add a sync, and instead of macro println we will use format, and here we will write hello from Rust web server. Okay, and let's write, yeah, here is our greeter function, sorry for that. Here function greet, okay, and implementation responder. Okay, so now let's write our main function, also sync main, okay, and std result, grab anything here, http server, okay, new brackets, and here, okay, write app new dot route web get dot to we call greet. Okay, and here we will do dot bend our local IP dot 0.0.1 port 8080. Oh, sorry. 127.00.1 and port number 8080. Okay, and here dot run dot await. Let's save here. Okay, so let's review our code again, that make sure that we have no anything written wrong. Route and then bend. Okay, so to explain what's going on here, the first line here, this one, okay, imports the necessary modules from the Actix Web crate. This function, async function greet, defines an asynchronous function that returns a response. The inside main functions HTTP server creates a new HTTP server, and after that sets up a route that responds to GET requests at the root URL with the greet function. The bend here bends the server to the local machine on port 8080, and run await starts the server asynchronously. So now let's run the program, and cargo run. Now it's fetching the dependencies and requirement for Actix. So let's try and navigate to here, and let's write 127.0.0.1 8080. Okay, it needs to be run. So where are we? Target. Okay, debug, and there is our program here. Let's run it. Okay. Yeah, I understand, because it seems we didn't save the file, and let's change something here because it's web and HTTP response. Okay, and okay dot body. Okay, here the explicitity of HTTP response create an HTTP response with a 200 OK status, and the body will be the text. And we need to change what else. Yeah, I think we are good to go. Let's save the file, and add new route. We are good to go. Let's do cargo run again, and blocks only allowed inside sync function. Okay, so let's do here sync again, and let's compile, and main function is not allowed to be synced. Let's see what's going on. Yeah, it seems we forgot to add a macro here. Okay, which is Actix -web _web. Main. Let's save the file, and let's run again. Run. So we have another error. Use of undeclared type HTTP response. Okay. Yeah, Teams, we forgot to add it here. Okay. HTTP response. Let's save the file. Let's run again. Okay, this is not error in the root. Okay, that's the good about Rust, that clear error to understand what is going on. And here, yeah, HTTP server. Yeah, it seems we had a mistype here. So yeah, this one is capital S and here is capital S. Let's save the file and we run again. That's a sneak peek of being programmer or developer. You deal with errors more than successful compilation. You will be lucky if you run your program from the first time with no errors. So now, as we can see, our server is up and running and ready to receive our requests. But before we finish this, let's say that what I did here, Actix _main, this is a macro from Actix Web, automatically sets up an sync runtime using Tokyo. So and this function, async function greet, as I said before, I think this function remains sync as it's an endpoint that could potentially perform async operations, like reading from a database or making HTTP requests. So yeah, for now, let's go and check our message here. So yeah, hello from Rust server, and our web server is up and running, and as we can see the output. So now we finished our second example using Rust, and that's it for today's introduction to Rust on openSUSE Linux. We have covered installing Rust, setting up VSCodium, and building real-world examples like a line counting tool and a basic web server. Rust is an incredibly powerful language, and I encourage you to explore it further. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell. Thanks for watching, and I will see you in the next one.